Robot Talk is the podcast that sits down with roboticists from around the world and asks them the questions you always wanted answered. Like, did you build that at home? And how does that thing work? Hello everyone! Welcome to Robot Talk. I'm your host, Claire Asher, and this week's episode is about building and programming robots at home. From 3D printed designs to coding and electronics. But first, don't forget to check out the Robot Talk shop at robottalk.org/shop, where you can get your hands on some awesome Robot Talk merch. Share your love for robotics with the world with one of the Robot Talk t-shirts, stickers, or mugs. And a quick shout out to my new Patreon supporter, Laura. Thank you so much for your support. Welcome to the Robot Talk community. So, without further ado, let's get on with this week's interview. I recently had a fun conversation with Kevin McAleer from kevsrobots about how to get started building robots at home. Today, I'm talking to Kevin McAleer, robot maker and host of Kev's Robots on YouTube. Hi, Kev. I'm excited to have you on Robot Talk.
Hi, how you doing?
So you have a background in IT and computer science. So what made you decide to take the leap from the digital to the physical and start making robots as a hobby?
Great question. So I bought a 3D printer about 6 years ago. It was one of these cheap Chinese clones of I think it's a Prusa. And this got me into sort of 3D printing things. So I was trying all the different models that are available out there. And I came across this very small robot. I've actually got it next to me here. Little handheld robot. It's kind of a desk-sized one. Has little tracks on it. And very, very quick to 3D print. Doesn't require any screws or glues put together. And I was absolutely hooked on this. I was like, this is amazing. What else can we do with this 3D printer? What else can we do with this robot? And I'd always been interested in the idea of robots, but I'd never really built my own until the 3D printer came along. That kind of unlocked something in my brain to do with what is possible. I think it was to do with the physicality of it.
Yeah.
I've got a little Venn diagram here that I often talk about with robotics. So it's kind of like the intersection of software engineering, mechanical engineering, and electrical engineering. And right in the middle, in that sweet spot, is robotics. So software side, I've always been tinkering around with things. And as my profession, as a day job, I'm a project manager. So it's very hands-off when it comes to the IT side. And I'm very much interested in all things computing. So yeah, I think as well, it was kind of the right time for this to happen, this discovery with the 3D printer. Things like Arduinos were coming around, becoming more popular, more books were available for that. I picked up a really cool book that was called Arduino Projects for the Evil Genius. I've since met the author of that, a good friend with Simon Monk.
Okay.
He's a very interesting person. So yeah, kind of got hooked on Arduino. It's very easy to use, quite low price point to get into. So $20 for an Arduino thereabouts. And yeah, all the other parts are quite cheap as well and quite available. So putting together a robot such as this Mars robot was quite trivial to do. And there's all kinds of things that unlocks, how far can you push this processor on this robot? What else can it do? What other kind of sensors can you add to this? So it's got this like ultrasonic rangefinder. It looks like a little face on the front of the robot. And it can measure distances using sound, using ultrasound. But there are different types of sensors that you can add to this. And one of the things I discovered was there wasn't really a single place to go to for hobbyist robotics to find out more information on what you can do, particularly with that robot as well. This is called a SMARS robot. It stands for Screwless Modular Accessible Robotics System, SMARS.
Right, yeah, definitely not a tortured acronym there.
Sounds like it. So yeah, I didn't design this myself. I have since added to the design of it and done lots of variations of it. But there's lots of nice innovations in here. This is completely 3D printed. And things like these tracks, you can see these little white bits on the pivot points. That's just 3D printed filament, just chopped off and put in so these can move around. And it means it's got a really good traction. It can go over pretty much any surface with its little wheels. And then, programming it. I've learnt C++ at university many, many moons ago. And the Arduino platform is very, very similar to C. It's not quite called C. I think it's like processing is the language it's based on, which is a sign for artists, I believe. They would do sketches, and I think some of that nomenclature sort of moved over to the Arduino platform still, so they still call their programs sketches. But it's quite a hard language to teach and learn, I would say, as a beginner. As somebody who wanted to sort of tinker with robotics, C is quite specific on how it likes things to be. You've got to have all your curly braces and your semicolons at the end of lines, and it's case sensitive. So if you're a beginner getting into robotics, that's probably quite a hard route. And I think that's one of the reasons I've pivoted over to MicroPython, because that's very easy to teach. It's very pseudo-code-esque. It's very easy to read and write. And you don't need to compile the code. You just write it and it runs immediately on your microcontroller.
Right.
So I think, it was the kind of intersection of 3D printing, availability of Arduinos. We still at the time had shops like Maplin, where you could go and buy things, parts and whatnot. And I found that there wasn't very many resources available. So I started a website called smarsfan.com. And that's where I kind of put all the information that I'd found about this robot, the parts you needed, how to build it, the actual design files for how you create these in a 3D software like Fusion 360. They weren't published. You could just download like the STL files, the 3D printable files, but you couldn't really change them. So I recreated these and measured them with some calipers and put the steps together. They were some of the very first videos that I did on YouTube, was just how to recreate this robot yourself so that you could then modify it in whichever way you wish to do.
Yeah.
So, and it was in creating the videos for that website that I got into YouTube. It's kind of like a side hustle that ended up becoming my main hobby, teaching people robotics.
Yeah, I think it's interesting that the question I asked you was, how did you transition from digital to physical? And you did that with literally a 3D printer, which translates digital into physical. So
absolutely,
it seems quite appropriate.
Yeah. And I think there's something that people who learn to program for the first time, there's kind of a dopamine rush that you get when your code works and the thing that you created runs. Well, you can amplify that many times when it's a physical thing, when a physical thing moves in response to your code. And even better when it responds in response to a sensor that you've programmed to respond. So, an arm moves or the robot detects that there's an object in front of it and follows it or turns around or whatever the thing is you program it to do. That dopamine hit that you get when your robot actually works is just fantastic.
Yeah.
Keep me coming back to building more and more.
Yeah, I can imagine. So, I mean, you've got an amazing array of stuff in your backdrop there.
Yes.
And I've been perusing your website and some of the different designs you've made. And they're quite varied. So, my eyes are always caught by the animal-inspired designs, but you've also got some kind of more practical creations. So where do you get your ideas from? So I think one of the main areas I get the ideas from is if I've got an idea that I want to teach a particular learning point, I will think, what would be the best robot to showcase that? So, for example, I created this little Haybot, this little robot I've got here. So it's got another ultrasonic rangefinder face on it. There's a Raspberry Pi Pico on the back as its brain, and it has this little hand that can come round. So when you put your hand in front of it, it'll come round and give you a high five, a little crisp high five. And it's really just to sort of talk about how these stepper motors work, because it doesn't have a servo. It has a stepper motor inside. And the difference is kind of how you get the motor to turn. And it's quite involved in the stepper motor. You actually have to switch on and off the different phases of the magnets to get it to turn round. So it's quite interesting. It's quite close to the physicality of how that works when you're programming it. Whereas the servo, that's quite abstract. You give it a pulse width modulation to define a particular angle. And you've got to explain how that works. What's a pulse width? How do you generate one? And why is that 45 and that 90 degrees or whatever? So often the robots have a single purpose in mind. Another one here, which is, this is the BurgerBot platform that I created because it's simply just a round shape. And this one has a little LiDAR on it. So this little light emitting apparatus can detect distances, but in 360 degrees. So it can sort of sweep round and it can tell you all the different distances of everything around it. And you can put that into some other software and map where you are.
And using some clever algorithms, you can actually detect where you are, where you're moving within that 3D space while maintaining a map and plotting a path to where you're going next. That's quite advanced, that, but you can do that with microcontrollers. So yeah, I think a lot of the ideas are, I might see something online and think, oh, I want to do that. How could I do that using MicroPython, using a Raspberry Pi Pico, using the kind of tool set that I know already? And can I do that in a really simple way that I can then teach to other people to do? And the teaching to other people bit is really just me wanting there to be more robots out there.
Yeah, it's interesting that you're kind of now motivated by the desire to teach rather than like, I want to make this cool thing for myself.
Yeah. And I think that's, again, it's more selfish than that. It sounds quite altruistic now, you say. If I make something really simple to teach, it means it's easy for me to remember. It's easy for me to document on my website, which is just my second brain. This is where I remember, how did I do that thing? And then they become kind of building blocks for later projects. So, I've got this little robot head behind me here.
I was tempted to ask you about that.
Yes. So this little white robot head behind me looks like the robot from iRobot.
It does.
That movie a while back. That's called InMove, the actual project. It's a French designer who created that. He modeled an entire humanoid robot.
Wow.
And then sliced it up so you can 3D print each piece, and then you can move them around with servos. But he did that using Java, which is I think it's quite an ugly language to be getting into robotics with.
Okay.
And it requires quite a lot of power computing-wise to do stuff with compared to just a regular microcontroller. So yeah, I was like, I'll just print out the sort of torso part, the arms and so on. And I got out of my depth real quick on that one. That was I think that was the second thing I 3D printed was the robot head. Because I was like, well, let's build a full 3D humanoid robot.
Yeah, what could possibly go wrong?
How hard can it be? This was so easy to do. How hard can it be? Yeah, and that was where I thought, well, I need to learn Python because that seems to be a much easier language to learn. And the Raspberry Pi, gets its Pi name because of Python.
I didn't know that.
Yeah, these Raspberry Pis are a full Linux computer. And you can do all kinds of really clever stuff, particularly on these newer ones. Do all the machine learning, the large language models. You can run all those locally on the Raspberry Pi without any internet connection. And therefore, that opens up all kinds of possibilities from a robotics perspective. So, yeah, that robot behind me has a little camera in one of its eyes. And as well as being able to move the eye around and follow people around the room, you can use OpenCV, the library for computer vision. So you can detect people's faces, posture, count objects. But it's really quite trivial. You just sort of ask the library to tell you, and it'll give you an array back of what it can see, and you can do actions based on that. So one of the fun projects I take with me to lots of different events is a little robot I can wear on my shoulder, a little companion robot called Bubo. And that has the similar kind of camera in its eye. And if you do a peace sign for sort of 3 seconds, it can detect that you've got a hand. It can detect that you have 2 fingers, and it can even tell you which 2 fingers on which hand are being held up. And that's the signal for it to take a picture. And then it will process the picture. It runs it through a little pipeline, adds a transparency things to it so it can say, I met Kevin at whichever event it is. And then it will tweet that out.
Awesome.
When Twitter was a thing, it would tweet out. So that was quite an interesting stack and quite an interesting set of problems. Tweeting out a message, if you tweet out the same message more than twice, Twitter will say that's a spam.
Like a bot, yeah.
Yeah, it's like a bot. So I had to come up with a little algorithm to pick from a set of certain different words and then assemble together a message that was kind of the same. So instead of saying hello, it might say hi, and there might be 20 other different, opening responses, and then build up a message from there to tweet out. Using robots to hack robots.
Yeah. The stuff you just described about computer vision is amazing because, what was a whole PhD's worth of research a few years ago is now just open source and available to anyone. That's incredible.
That's right. And these are like Lego blocks. You can just bring that into a project and just say, I want machine learning to do this. I want a large language model to do that. And it becomes trivial to put these things together. Yeah. So one of the projects, I think it's just on my back shelf over there, is a little Walkman-like robot. I say robot, it's more of it looks like a Walkman from the 1980s. So you've got the headsets with the orange speakers on it. And you can talk to this AI and it will talk back to you. You can ask it questions and it's all offline. It's all Raspberry Pi 5 under the hood. And it's really quick to respond back. And it's just running a large language model behind the scenes to do that processing of what you've said to it. There's also speech recognition and speech synthesis. And again, these are just like Lego blocks. When I was like coming up with the idea for this project, it was like, I need to build an enclosure for this. I need to just check that the headphone and the headset work just by plugging in, which they did. And then just assembling the Python libraries to make all this work together. And it was an afternoon's work.
Wow.
It was really quite trivial. So that was fun.
Yeah, that's really cool. So I've had a lot of hobbies over the years, and I have a habit of taking on things, getting really excited, buying all the stuff, doing a little bit of it, and then kind of abandoning it, either because I kind of just lose interest or it's harder than I expected.
Yeah.
Why have you kind of stuck with robotics as a hobby?
Yes, I'm glad you asked this one. I have lots of interest in hobbies, and I decided a while ago, I was watching a video by Casey Neistat, that YouTuber, who became very good at YouTube. And he said, if you have lots of hobbies, and he kind of drew this out on a little chart, he said, you might be good at each one, and there might be one that you're slightly better at than others, but it's quite a wide breadth of skills. Yeah. He said, if you pick one thing and you stack all your skill into that one thing, you'll achieve a lot more than you will if you spread your skills out. And that kind of chimed me a little bit. I thought, well, I like robotics. I've always wanted to have a robot of my own, this humanoid robot companion or, robot butler or whatever. And how could I go about achieving that in my own lifetime? And it would require kind of putting aside all those other interesting hobbies, as interesting as they are, and doubling down on the robotics. But robotics in itself, if we go back to our little Venn diagram of the three intersecting areas of knowledge, if you get bored or fed up with your engineering side, your electrical engineering side, because, your circuits are not working the way you expect them to, you can then move over to maybe the mechanical side and the physicality of the robot, the 3D design. And then you move to the next week on, the software engineering side. And you can keep moving around these different areas of expertise and leveling up each of them without really getting bored. So I can never get bored of robotics for that reason, because there's just so many different aspects to it. You could just drill down onto one of those things and spend a lifetime learning more about it. Robotics, just as a general area, there's so much to learn and to do there.
Yeah, I mean, this is something that comes up on the podcast quite often, is just how incredibly multidisciplinary robotics is. And I think you could add some things to your Venn diagram, like art and design kind of elements.
Yes.
You can pull in biology if you want to do some bio-inspired robots.
Yep.
If you're doing stuff that interacts with humans, then you've got psychology and all of that kind of area. So, I completely agree. It's incredibly diverse, the different skills and the different elements of it that you can bring in. Yeah.
And some of them, some things you can also be, as a hobbyist, at the bleeding edge. And there isn't any more known than what you know as a hobbyist. And that can be an interesting thing, because you might think, I thought there was a lot more to know after this. No, that's as much as we know in that area. That's as much as we've achieved. That's open to innovation there. That's quite an interesting thing to be aware of.
Yeah, that's exciting. So, on your journey as a maker, what has surprised you the most?
Yeah, so it's taken me some really interesting places. I've met people I would never have thought in a million years I would have met. So Raspberry Pi, for example, every week they have a Maker Monday thing on all the social platforms where they say, show us what we've been making, particularly if it's with a Raspberry Pi or a Raspberry Pi Pico, the microcontroller version, and we might put it in the magazine. So I was like, this is now a mission. I must get in the magazine every month. And sort of a reader's section at the back. So in doing that, a couple of my projects they thought were of interest, so they covered them as like a double-page spread in a couple of their magazines. So that was like, that's interesting. And then you get on the list of people that they're friendly with, because, it's a UK product. I quite like, promoting that, something that we do well. We make Raspberry Pis.
Yeah.
And I then got on the list of people that get notified when they have a new product coming out. So you get the product a couple of weeks or months before everybody else, you get to play with it. And then when it comes out, you've got video and you can get a nice little spike on your YouTube statistics to say that this has performed really well.
Yeah.
And then, other people then get in touch and say, I like the video you did on this. Either would you be interested in promoting our product? So I've got a whole bunch of of WaveShare stuff, for example, on my desk over here. And Sun Founder, they like to send me a few of their things to look at and review. In fact, Waveshare sent me 2 robot arms. I've got one just there behind that head. I've not done very much with that yet. They've sent 2 of these, and I need to do something with that to sort of showcase it. And one of the things what I was thinking was putting the camera on it so that I can make the camera move and do some nice sweeping shots and so on of things I'm filming.
Yeah, that'd be cool.
It'd be quite cool to do. So yeah, I would never have dreamed in a million years that people would send me robots worth several £100 each.
Yeah.
And many of them. I've got 2 VM robots. VM are a company that makes software. They're kind of trying to make it really easy to do no-code robotics. So yeah, they sent me these. They don't make these, but they sort of program. Again, driven by a Raspberry Pi inside. It's got a camera on front, so you can do all the face recognition, object detection. It's got some nice beefy motors on there to drive it around the floor. So yeah, that was quite nice because it's like professionally made. I've got 2 of those. I've got 2 dog robots.
Nice.
They are real fun. One of them is like very, very well made. There's about £1,000 worth of robotics. But yeah, it's interesting to see how they make them. So when I went to visit VM and they have their lab, it's just like this lab here. They just have more expensive robots knocking around. But they have people doing the same kinds of things. So yeah, I think the places it's taken me, I made a commitment to go to more physical events after COVID. So there's Maker Central in the UK. We have that in about May each year at the NEC. And that's where lots of makers get together and kind of showcase what they've done. And you can also buy all kinds of tools and things and see what's available out there. So I've met quite a few people through that who are based in the UK. And there's a couple of other people, like Zyla Foxlin, for example. She does a lot of builds online. I think she started out in robotics, but now just does general woodworking builds and stuff, building an aircraft at the moment.
Cool.
And they have other makers like James Bruton. He's quite a famous UK roboteer. He makes all kinds of projects, lots of weird wheel projects. He's done lots of omni wheels and self-balancing robots and things.
Cool.
So I met him, I interviewed him very early on in my YouTube career. He was very generous with his time with that one. So I would never have thought that I would be meeting him. And then, yeah, people like Eben Upton from Raspberry Pi. I interviewed him for the Raspberry Pi 5 launch. I met Massimo Banzai at the Rome Maker Fair. So that was quite interesting. Try and tie in my family holidays with these maker events. So yeah, the one that we went to, we've been to for the past 3 years, is Open Source in the US in San Francisco. It's a really nice place to visit. And San Francisco is kind of, where all the technology stuff happens, all the startups and whatnot. So it was very interesting to go there and meet some of the people and kind of showcase my stuff there. And yeah, more people came to the stall that we had. And we just had these little robots just sort of showcase what can we do with these little robots. And people always sort of say, do you sell kits? I tried selling kits. It's very messy, what with Brexit and the complexities of tariffs and things nowadays. It's quite a messy business to sell kits, and it distracts you from building more robots, I guess, really. The opportunities that it's opened up, I would not have thought in a million years that these things would have been accessible to me. Just by sharing what I've learned has opened all kinds of doors. So yeah.
Yeah.
Very, very enjoyable.
That's really cool. No one has sent me any robots yet. I'm very upset. There's still time. If any robotics companies are listening and they want to send me a robot dog, that would be awesome. Also, you were talking about the robot arm. Have you seen that recent, I don't know what your musical tastes are, but OK Go put out a music video a few months ago where they were dancing with the big robot arms? Yeah. Yeah, that was very cool.
Yeah, that's one of the things that I think set a bit of a cheat. I don't know if you've covered this on any of your other shows, but a lot of those Boston Dynamics videos where they showcase robots dancing and things, they are heavily, pre-programmed and heavily choreographed in advance. And they don't show you the ones where it falls over and so on. So it kind of sets an unrealistic expectation of what's achievable for the average person, I think, because you think, why can't my robot dog walk in a straight line, over reasonably straight terrain without falling over or something? Yeah, I think that's one of the interesting things. We seem to be on a bit of a cusp at the moment with robotics, where humanoid robotics, that seems to be, I know you did a show on this one, I was listening to that just before actually. Why do we always want to build humanoid robots? I think it's because we see ourselves in them. Yeah. We can relate to it more as a robot, because your house has already got loads of robots in there. You've got microwaves, that's a robot. You've got washing machine, that's a robot. Vacuum cleaners. They have the name robot now at least, but they're all very good at doing one specific thing, and they don't look like a person. So I think as soon as you give it eyes and hands and the ability to move around, you kind of cross a bit of a threshold there of uncanny valley. Is this thing really thinking, or is it a machine like a microwave, or is there something more going on there? But I think that it hasn't really been possible to build reliable humanoid robots until maybe the past 5 years. And I saw one at open source. It was just wandering around, just walking around. And I was like, that's incredible. And the things that when I see that, I start thinking about what's the battery life on that? How long can that stay upright? Because that takes a lot of power to do that elegantly. And a lot of processing power as well, just to keep it upright. All that sort of balancing and so on takes quite a bit of work to do. And then simple things like if you wanted a robot to, empty the laundry and put it into the washing machine, for example, that's a really complicated task to do. It's not something you can pre-program steps-wise. Even picking up a sock, for example, a soft material that could be in lots of different orientations, and it's got a simple grabber to pick that up. How much force does it need to grab the thing? If it drops it, can it then pick it back up again from a different position? Can it keep in its mind what it's trying to do and at the same time be safe, around people and animals and other objects? These are really like non-trivial things to do.
Absolutely.
But for us, that would be a really useful thing for a robot to do for us. And I think the humanoid shape moves it from just being a specific task like a microwave, washing machine, or a robot vacuum cleaner to being a general purpose robot. So I think we're on the cusp of general purpose robotics. And for me, that's like the most exciting thing that we could have.
Yeah.
About the price of a car at the moment, I believe those robots, about 16,000 and up, and the price will come down, and the battery capacities and charge will improve as well.
Yeah, I haven't seen a humanoid I was going to say in the flesh. That's not quite the right. In person. And like you said, a lot of the videos that people put out maybe seem like it's acting autonomously, but it's been pre-programmed. So and also a couple of years back now interviewed one of the people who had consulted on Big Hero 6. And we talked about like how big and heavy these humanoid robots are. If one of them falls on you, it's going to do a lot of damage. I really want to see like a big inflatable multi-purpose robot like Baymax. That's what I'm waiting for.
One that's safe.
Yeah, exactly.
Yeah, and there's a lot in there. The safety requires the robot to be aware of many other things other than the task at hand, and aware moment by moment, not just generally aware. Through some sense, but it is aware of the consequences and what it's doing. So that's quite a challenge. There's a lot more AI leaps that we need to make before we get to that piece, I think.
Yeah, absolutely. So we have an audience question from Andy on Twitter. It's kind of a two-part question. Andy says, I want to know where to get parts and where to ask for advice. And then the second part of the question is, how can I find a robot hobby group for adults? I only have college courses or classes for children near me.
So if you know exactly what part you're looking for, then places like AliExpress can be a really cheap way to get them. They're probably the cheapest way, but not necessarily the fastest way. If you want to get something like next day, then Amazon is your friend, but you'll pay a premium for that because of that next day, and also the fact that they're kind of handling that for you, because AliExpress, you might not get what you asked for. It might be a knockoff that isn't quite right. One of the projects I've got at the moment I'm building is a little drone. It's a little flying robot. Lots of interesting aspects to that. And these little sensors for measuring, the gyroscopes and the magnetometers. There's a lot of knockoff ones that don't do what they say they should do, or they're mislabeled. And you have to buy them to find out that isn't the right one, even through Amazon, in fact. So they're the places if you know what you want. There are lots of places that sell kits of kinds. So in the UK, we've got like Pimroni based in Sheffield, and Pi Hut. They do a lot of Raspberry Pi-based robotics stuff and kits. Some of them you just assemble them. Some of them are soldering kits, whichever you prefer. And then in the US, you've got places like SparkFun, DigiKey, Adafruit, and they do all kinds of parts and components and kits and things as well. So it depends what kind of robotics you're interested in exploring, what kind of parts you need, whether you've got something in mind or whether it's just generally putting stuff together. And one of the reasons I build these small handheld or desktop-sized robots is because these are quite cheap to build, quite easy to make, and there's not a lot to go wrong with them. And if they do, it's quite easy to swap them out. You're not committed to like a full humanoid robot
Yeah.
costing thousands of pounds. There's lots of companies who specialize in one thing, like Hobby King does lots of servos. So if you want to buy specific size of servo that can do specific things, they will help you with that. And if it's a 3D printable part or a non-electronic part, you can probably design and make your own. Things like PCBs, you can have these, manufactured yourself if you know how to do that. You can get them sent off to a company like PCBWay or whatever, and just drop the parts in. That's another innovation that's happened, in the past couple of years, which I think has really changed a lot of robotics. Just the ease of getting PCBs manufactured. You can even manufacture silicon, which is just mind-blowing. There's an organization, Tiny Tape Out, and if you know how to put together a chip design, you can have that chip fabricated, which would normally cost like millions of dollars. But the idea is lots of people have got together, they all get one chip manufactured at the same time that's got lots of little pieces you can break off, and yours will be one part of that.
Right.
And then you can put that into a microchip of your own. So you can even make your own silicon now, which is crazy.
Amazing.
And then one of the things I didn't know until earlier this year, a college got in touch with me, Derby High School, and there is a annual competition, First Robotics. And I've not heard of First Robotics before. And because it's all schools all across the world competing with their robots, there is all the shops and infrastructure and tutorials around that as well.
Right.
So kind of leads on to the other part of the question about like learning and so on. So obviously YouTube is your friend. There's videos on every single thing you could imagine there. Mm-hmm. Lots of online places are available, like YouTube, for watching videos. I've got my kevsrobot.com website, which I've been putting lots of information in. There's lots of free courses on there, for example. So if you want to get into robotics, I've got a Robotics 101 course on there, which will take you through what is a robot and so on. And you can learn about how all the different parts of the robot will work and build your own from there. And then there's specific courses on, specific robots that I put together, like the BurgerBot, how to build one of those, for example.
Brilliant. I think the hobby robotics community is very grateful for your contributions and all of the amazing resources that you've provided. So yeah, thank you for that advice. Kev, it's been really fun chatting to you today. I've been speaking to Kevin McAleer from Kev's Robots. Thank you.
Bye.
Thanks for listening. If you enjoy Robot Talk, I'd really appreciate it if you could share the podcast, subscribe, and leave a review. And check out @Robot Talk Pod on social media to see a photo of 2 3D printed robot heads that Kev built, called Isaka and Sonny. I thought you might like to hear a sneak peek of this month's bonus episode.
For some engineers, I believe that it's kind of a huge challenge to create something like us, right? Because we treat ourselves like a ideal species, right? So for engineers, for scientists, creation of something which is ideal is a challenge, right? I think because we are social beings, we are social animal. When we think about potential implementation, potential practical usage of robots, we have to remember that robots have to operate in our environment, interact with real humans. That's why we prefer such shape, such appearance, because we can, by just simple looking, we can understand, we can, predict their behavior. In this situation, when we see, for example, hands like that, we know that, okay, we can shake hands with them. For us, such robots seems to be very predictable machine, right? So there are lots of reasons like that. But of course, sometimes we're afraid if the robots are too human-like, right? It's the effect of uncanny valley, probably we'll talk about later.
Yeah. Since, we still don't have robots that think like humans or that are, capable of many of the things that humans do you think that sets up expectations for people? They see a humanoid robot and they expect it to be exactly like a human, and right now they're not.
Today we have AI tools like ChatGPT, Claude, Gemini, which can really think well and can reason now. They can create plans of actions. Mm-hmm. And currently we have the moment where this intelligence can be seen on a screen, can talk to us, but cannot do yet any actions in real world. So we are in the phase of embodying and making real actions in our world to potentially help us with dangerous work or for fun or for many different other reasons. I think that these tools can even be faster in thinking than humans. They have immediate access to the whole knowledge they learned during the training. So the end effect can be even better than human workers. For example, we can create software with Cloud Code, with GitHub Copilot and other tools. It's all virtual, but the same way the humanoids or other robots can create the plans of actions and later execute them. So we can teach them to chores, anything really we want. But the challenge now is really the hardware and the method of teaching behaviors, not only thinking, but how to move our limbs, how to move our hands to do precise manipulations like humans do. And then they become very, very useful.
If you'd like to hear more from this bonus episode, sign up as a supporter on Patreon by going to patreon.com/Claire Asher. You'll get access to the full catalogue of bonus episodes, plus lots of other cool supporter perks. Next week, I'll be speaking to Shapa Siratunga from the University of Cambridge about robot anatomy and design. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk Season 6 is sponsored by the Hamlin Centre, Imperial College London.